In this lesson, we are going to graph from vertex form. What we learned in the previous lesson was the different patterns that were based on the vertex form. So to graph a quadratic function from vertex form, which is y is equal to a times x minus h squared plus k, you need to identify a couple of things. First of all, the location of the vertex. What we learned is that the x-coordinate is the opposite of h. So whatever h is, it's the opposite of that. And the y-coordinate is the same as k. Secondly, you need to identify if the function opens up or down, and we learned that it's up if the coefficient is positive and down if the coefficient a is negative, which is in green here. And thirdly, you need to identify another point on the function, and this shows how wide or narrow the function is. You could substitute any value for x to get a value of y, but it's usually easiest to substitute x equals 0 into the function to determine the y-intercept. You'll see how this is useful and how it shows how wide or narrow it is. Okay, so let's go ahead and graph two functions. It says graph the following quadratic function in vertex form, label the vertex and some other point. So in this particular question, we know that the vertex is the opposite of negative 4. That's the x-coordinate. So your vertex will be at positive 4 and the same as negative 8. So positive 4 and negative 8. What we also know, so that point is right here, we also know that it opens up. However, we don't know if it's this wide or if it's this narrow or if it's this wide or exactly what it looks like. So that's why it's useful to find some other point. What I would like to do is go ahead and find out we don't know, I'm going to go ahead and find out where the y-intercept is. That will be useful. We know that at the y-intercept x is always 0. So if we go ahead and substitute x equals 0 into the function, we will get the y-intercept. So substitute x equals 0 to get the y-intercept is often useful. So we're going to substitute 0 in for x here. So it's y is equal to 0 minus 4 squared minus 8, which is negative 4 squared minus 8. Negative 4 squared is positive 16 minus 8, and that's 8. So your y-intercept is positive 8, and that's useful because now we know that this is a more narrow type of function. So your quadratic function would look something like that. Okay, in the next question, what we know is that the vertex would be at negative 1, and because there's no constant term on the end, you could add a 0. So it'd be at negative 1, sorry, I'm wrong, the vertex would be at positive 1, the opposite of negative 1, and 0, so there's your vertex. And if I would like to get the y-intercept, I would substitute x equals 0 again. So it'd be y is equal to negative 2 times 0 minus 1 squared, which is negative 2 times negative 1 squared. Negative 1 squared is positive 1, so that's negative 2 times positive 1, which is negative 2. So that's your y-intercept, which is right here. And we knew that this function opened down based on the coefficient being negative. If you're in my class, you would do this one formative question and have me initial it, and we will move on to the next lesson.